Algebra 2, Target 15. I can factor polynomial expressions. Today's focus, using common terms and special factoring patterns. Remember from previous targets, we've had certain types of factoring. We've had the general trinomial. That would be a quadratic. To factor that, we used the box method. The perfect trinomial square, we also use the box there. There is a shortcut if you recognize that half of this and the square of that are the same thing, which happens to be 4. But we focused on the box. The difference of two squares, you can box that as well using the middle term of 0, or recognize these as conjugate pairs. And then you had common monomials, looking to see what's in common. Right? That's like what we're doing in each row of the box. Well, today we're going to look at factoring completely. What does it mean to factor completely? Well, you can read this and you can see that factoring completely means after you've factored, you look and see, can you factor more? For example, this one is considered factored completely because you cannot break it into more groups using whole numbers. This second one is not considered factored completely because you take one of the factors, it can be broken down further. So let's take a look at this one. We got the polynomial x cubed plus 2x squared minus 15x. We want to factor that completely. A couple things you want to remember. First off, look for a common term. That should always be the first thing you do. If you pull out a common term, a lot of times it makes what's left a lot easier to factor. Another thing you should do is look at the degree. Okay, our degree is 3. That means you may have up to 3 factors. Not always. Some factors may be non-factorable, but when your degree is 3, you may have up to 3 factors. So let's start by looking for common terms. And as we look here, we can see that each one has an x. So I'm going to factor out an x. We got x squared plus 2x minus 15. And then what's left, that has a degree of 2 that may be able to factor further. And that's a degree 2. That's a trinomial. We would factor that using the box. X squared, negative 15. What multiplies to negative 15 and adds to 2? That's 5. And negative 3. So we got x minus 3 and x plus 5. So our factored of just this part is x minus 3 and x plus 5. And then we make sure we remember the x. Now I said the degree was 3, so you may have 3 factors. Our 3 factors are 1, 2, 3 right there. You'll never have more than your degree. Right? So factor this completely. Now we could have up to 5. Not guaranteed to have 5, but there could be up to 5. We'll start by looking for common terms. 2y to the 5th and 18y to the 3rd. Do they have anything in common? Well, yes. They're both multiples of 2, and they have at least y to the 3rd. What's left when I pulled that out is y squared minus 9. Do either of those factor further? Well, yes. Y squared minus 9 can factor further. That's a difference of squares. We can break those into 2 conjugates. The 2y cubed, that does not factor any further. But the y squared minus 9, that's y minus 3 and y plus 3. We could have up to 5 factors. We've only got 3. But there's 3 factors accounted for here with the power of 3, 4, and 5. So our factored form is right there. Pause this one, give it a try, and then play the video. Take a look. We could have up to 4. We need to start by looking for common terms. It looks like they're multiples of 4 and has at least z squared. When we factor that out, we get z squared minus 4z plus 4. This is as low as we can get. This we should try the box and see if we can take more out. All right, so we got z squared and 4, but multiplies to 4 and adds to negative 4. Well, that's negative 2 and negative 2. So we got z minus 2 and z minus 2. That's a perfect trinomial square. So our factored form is 4z squared times z minus 2, and since it happens twice, we say it's squared. So we got, it looks like 2 factors. This technically counts for 2. This technically counts for 2. And so that's where we get our 4 there. Now, in addition to difference of squares, there's also something called the difference of cubes. And for cubes, there's also a sum of cubes. This is when you notice you got x cubed or something cubed minus a number that is a perfect cube, or x cubed plus a number that is a perfect cube. When you notice that, they follow this specific pattern. Your sum of cubes, a cubed plus b cubed, would be a plus b, and then a squared minus the multiplication of the 2 terms plus the second term squared. Right? 8x cubed plus 27. Notice that 8 is 2 cubed, so this is really 2x cubed plus 3 cubed. You got 2 cubes that are being added. So the pattern, a plus b, there's your a plus b. And then a squared, 2 squared is 4. A times b, 2 times 3 gets us the 6 with the subtraction. And then b squared is 3 squared is 9. Same thing down here. 64 is 4 cubed, so it fits the difference of cubes pattern. So factor this completely. Which pattern does it follow? Well, that follows the sum of cubes. So the sum of cubed, if you go back and look at it, a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. What's being cubed here? Well, x is being cubed, and 64 is 4 cubed. So my a is x, and my b is 4. So we'll fill that into the pattern. We got x plus 4, and then a squared is x squared minus 4 times x, and then 4 squared is 16. So there is our sum of cubes. You look and you see, okay, what are the 2 things being cubed? Or basically, what's the cube root of 64? All right, number 9. Take a look, factor completely. Always look for what first? That would be common terms. They seem to have z squared in common. Let's see, 16 and 250 are both multiples of 2, so we can pull out 2z squared. That leaves us with 8z cubed minus 125. Now, look at this expression right here. Notice that 8, that's really the same as 2 cubed. So we got is 2z cubed here. And 125, well, that's 5 to the 3rd power. So this right here, that's a difference of cubes. The difference of cubes pattern, a cubed minus b cubed, that's the same as a minus b times a squared plus ab plus b squared, where a is 2z and b is 5. So as we complete this factoring, we're going to carry along the 2z squared. All right, this is a difference of cubes where a is 2z, so a minus b will be 2z minus 5. And then a squared, 2 squared is 4z squared. A times b, that's 5 times 2 is 10z. And then b squared is 25. So here's our factored form. Remember, we could have up to 5. 2 are accounted for here. 2 are accounted for here. And a difference of cubes, this will never factor. And 1 is accounted for here, so we got our 5 factors. So in conclusion, what you're going to do, you want to make sure you factor completely. So after you use one of your factoring methods, either the perfect trinomial, the general trinomial, the difference of squares, or the common terms, or the new ones, sum of cubes, difference of cubes, after you've done it once, you want to look at your factored form and see, okay, can this go further?